welcome to Lecture 1 of Superposition and Interference of Waves in Phys 1201. And in this lecture, we're going to look at an important general law of waves called the Principle of Superposition, which just tells us what happens when waves overlap with each other. The first thing we're going to look at is something we actually could have looked at when we were just discussing traveling waves, because it's not directly to do with superposition and interference. But we're going to need to understand this to understand a lot of the demonstrations on this unit. So now seems like a good time. And it's to do with boundaries, or the ends of systems. So we're going to start off by looking at a free boundary, also called an open boundary, or sometimes instead of calling it a boundary, we call it an end. And the point of a free boundary is that it is a boundary of a system where the pieces of the system, the medium at the ends of the system, are free to move. Nothing is holding them in place. One of the best sorts of things to look at to see some of these effects is what is called a wave machine. Now you can look at all sorts of things, but a wave machine has nice, clean, reasonably slow-moving waves that are easy to see. This wave machine is set up with free ends. All that means is that the ends are free to move. There's nothing holding them in place. And if I send a wave down it, so there's a crest, and watch. See that again. Most people initially think that when a wave gets to the end of the medium that it's moving through, it just stops. But what it actually does is it reflects back. And in this case, note, I send a crest down the wave machine, and what comes back is a crest. It reflects essentially unchanged in shape. Now, the ends aren't perfectly free. There's a little friction in them. And so the wave gets changed a little bit, but for the most part, when I send a crest, I get back a crest. So, if I now send a trough, you see that it reflects back as a trough. So, as we've just seen, when we have a free boundary, or an open boundary, the wave reflects off the end, and it reflects with the same shape that it had before. And I'll just superimpose the curve and the directions of travel showing this. Note how, in this case, all that's happening really is the wave is reducing in size. That's telling us that this isn't a perfect free boundary. There's a little bit of friction. Now, let's talk about the opposite extreme, which is a fixed boundary, also called a closed boundary, or again, sometimes say an end instead of a boundary. So, this is the case where the end of the system is somehow held in place. The medium there cannot move. Here's the wave machine again, but notice that now I have clamped the ends of it so that the rods at the very ends can't move. So these are now what we call fixed ends, or closed boundaries. And if you now watch a crest travel down, look, it flips and becomes a trough when it returns. And if I send a trough down, then it flips and becomes a crest as it returns. So, as we've just seen, when we have a fixed boundary, the wave reflects still, except it flips. It becomes inverted when it flips, like so. Now, I'll just note that these are not the only possibilities. There are all sorts of other possibilities for boundaries, largely things to do where it's some combination of free and fixed, not perfectly free, not perfectly fixed. But those are very complicated, and we'll restrict ourselves to looking at either perfectly free or perfectly fixed boundaries. We come to the main event of this lecture, and that's to look at what happens when one wave meets another. What happens as they're in the same place on the medium? And I've actually already mentioned this in an earlier lecture in this course, but now you get to see it. So I'm not going to tell you what happens. I'm going to get you to watch, and then you're going to figure it out. So here, I'm going to send a pulse. This is a crest that I'm sending down the wave machine, and it's going to reflect. And as it comes back, I'm going to send another pulse so that two crests meet each other. So watch it again in slow motion. And pay attention in particular to what is happening as the two waves are overlapping each other. So now you have seen the setup for the first of the two questions that I'm going to pose to you. When one wave is running into another, what happens? Here's the before and after picture of these two crests meeting, and I'll put the superimposed traces and their velocity vectors on. Now, if you look carefully at that, you can see what's happened. But let me pose the question very precisely. I'm going to name these two crests A and B and ask what happened. Did they bounce off of each other, in which case this crest here is A, having bounced off of B and now heading back the other way, and this is now B, having bounced off A and now is heading back the other way. Or, alternatively, did they pass through each other, in which case this is A, still going the direction it was going before, having passed through B, and this is now B. So you decide. You can tell by looking at them. You figure it out. Here's the wave machine again, and this time I'm going to send a trough down the machine, and you're going to see the trough reflect, and then I'm going to send a crest, so that we end up seeing a crest going to the right, meeting a trough going to the left. Except I'm not going to show you the outcome. I'm going to stop it just before, and then I'm going to ask you to predict what the outcome is. So here it goes. And I'll show it again in slow motion, like so. Now, you've already thought about whether waves pass through each other or bounce off of each other, and what it is exactly that goes on as they're overlapping. So you have theories, and so you're going to use your theories to predict what will the crest and trough look like just after they meet. Here's about what they look like before, the crest going to the right and the trough going to the left. After, which is correct, will they have bounced off each other, in which case the crest is going to now be going left and it'll be over here and so on, or will they have passed through each other, in which case they ought to look like this. And then the second thing you're going to predict is what will the medium look like at the moment when the crest and trough are overlapping the maximum amount. Again, here's the before picture. In the very middle, when they're overlapping the maximum amount, is it going to look like a big crest? Is it going to look like a big trough? Or is it going to look like absolutely nothing? So think about that, and at the beginning of the next part of this lecture, you will see the answer. This is the end of this piece of the lecture. If you're in my course and accessing this through Moodle, you'll now be asked to make your predictions before being taken to the next part. If you're just watching this on YouTube, then I would encourage you to write down which your predictions are before going on to the next part of this lecture.